Hello. Now we'll discuss about the arithmetic operator. We have already discussed about the few operators earlier, right? So let's start implementing add and subtract method over here. So what we are doing over here is we are implementing a vector class, right, which support the various arithmetic operator, but we'll assume that a specific number of dimension, right? Here we'll not assume that this vector have a specific dimension, right? So it can have the any dimension, right? Which will now, and again we'll kind of implement that components into the init method, right? So let's see that how it is working. Right now we are first implementing the real from the numbers because we want all the component of the vector to be the real number. So we'll use this real object, and this is a class vector over here. This is the init method we have here. We can pass any number of components. Right now we're checking that if the length of the component, because this would be the tuple, right? If the length of the component is less than 1, so it will raise value error that vector cannot be empty. Otherwise, it will take each element of the component and will check that whether this each element or each component belongs to the real number or not. If not, then again it will raise the error that vector should be all numeric. If this passes, right, so we'll kind of add all the components, right? We'll add all the components in the form of tuples, and we'll make it as an component attributes. Right now we have this length function which will give you the length of the component. Right now we have the property attribute over here. So this property decorator, so here we have this property object, right? So we are creating this component function as an property object. So this component functions returns you the component itself, right? And because this is a property object now, so you can access this method using the dot product, right? Using the dot notation. And we have this RPR method which will just gives you the which will just return you the how the vector looks like, right? So let's run this. Here we are running this, right? Now let's add a support for addition and subtractions to the vector, right? Here now we have this vector, again the same code we have this len function, we have this component property, we have this RPR. Now this functionality we are implementing, like validate type and dimension. What this will do is this will check that other value, right? So let's say that other value or like other vector is the instance of vector or not, right? And we are also checking that other vector belongs to the same length or not. So this function will help you to check whether this both object, right, both vector belonging to the vector and their length are same or not. Now we are implementing the add functionality over here. Now first we are validating the type and dimension are same or not with the help of this type and validate dimension function. If it is not, so it will return this not implemented. Otherwise, what we'll do is we'll take the component of both object, zip it, right, and add the element and add the real value for from both components over here, right? And we'll create a tuple over here, and now we'll pass this tuple to create a vector. So in short, when you add two vector, it will create a new vector, right? This is like creating a new vector over here. Now we have this subtract method implementation. Again we are checking whether this both object belongs to the same data type, that means vector or not, and their dimension are same or not. Right now we are returning, if it is not, so it will return not implemented. Otherwise it will take the subtraction of all the element, and again this case also it will create a new object of the vector. Right now let's run this as well. Now here we have the three vector we are getting. First two vector v1 and v2 have the two element, and vector 3 have the four element. Right now let's see the v1. Here we can see that now here we are adding v1 plus v2. What this will do, this will call the add method. Now it will check whether this v1, so here this like this function will be checked. Basically it will check whether the dimension and the type are same or not. If it is same, so it will do the addition of each component and it will create a new vector over here. So when you do this, it will do 10 plus 1, 10 plus 2, right? And then whatever the element will get, will pass that element to create a new vector, right? Here we can see that. You can also do vector 2 plus vector 1. Right? Now, when we try vector 1 plus vector 3, what is happening over here? Basically, vector 1 and vector 3 both having the different dimensions. So this will raise error over here. This will raise this error, right? And when we try to do this, it will raise unsupported operand type. So here we are catching the exception, and this is the error we are getting. Again, we are adding a vector to the integer. This is also not possible. So we'll check. This is not possible, right? So we are getting error over here. Now let's add a support for multiplication by scalar value. That means we want to multiply each element by the real number, or each element of the vector by the real number, right? For that, we have to implement the mul method, right? Again, everything will be same. Here we have implemented the mul method. Now we'll check that if the other object belongs to the real number or not. If it is not, so it will read this, so it will return this not implemented. Otherwise, Otherwise, what we'll do is it will take each component of each element of the vector and try to multiply that real number with that element, right? And now we'll create a new vector. So this will create a new vector over here. So we have this vector 1. When we do v1 into 10, this will ultimately call the mul method. First, it will print that mul called, right? Then it will try to check this operation, and then otherwise after that it will try to do this operation and create a new vector. So what this will do is it will try to take the loop of this 1 and 2. It will first multiply 10 with 1 and then 10 with 2. So we'll have the two element 10 and 20, and we'll create a vector using that. So here we can check that 10 and 20, and we are seeing this print mul has been called. So when you use the star operator, this mul method has been, like, mul method gets called, right? Again, what happens when you do the reverse operation? That means 10 into v1. This will give you error because we have not implemented this thing, right? We have not implemented that even the integer can do the multiplication of vector type, right? For that, we can use this rmul, which means this reverse multiplication. We can do this. Here is the implementation of rmul. We just have to simply call self into other. That's it. This will does the implementation of everything, right? Now let's do this. Here we have this v1 into 10 and 10 into v1. Now you can see when the rmul gets called, then it is calling mul object, and now it is doing. So when you call this reverse multiplication, right? Right, and after this reverse multiplication, it is saying that self into other. So basically, after it gets this reverse multiplication, it ultimately try to call this mul object, like mul method, and then it will do the operations, right? Now let's say that if you want to implement the dot product of two vectors, you can even do that, right? So you can take you can multiply each element of each vector, right? And then you can sum those multiplication value and get the one value, right? You can also do the dot product. So here is the implementation for that, right? Again, all this code is same, right? We have already discussed this, right? So here we are just changing this in this multiplication method. We are first checking that if the other object is the real number, we'll do this like we'll multiply with the other with each element, and then we'll create a vector, right? And if the both object belongs to the same dimension and same data type, right? So here we're checking that if this gets failed, that means it will, after that it will check this. That means if both belongs to a vector and having the same dimension, then what this will do is this will try to take the each element from the each vector, right, and try to multiply, right? Here we're trying to multiply both element object with each other, and then after that we'll kind of return the sum of that component. After all, this is a tuple, so we can take the sum of that, and if both gets filled, so it will return not implemented, right? And then we have also implemented the rmul, right? Here we have this two vector. We can, when we do v1 into v2, right, first it will check this is false. Now it will check this, which gets true, and then it will give you the value. Right? We can see that 11 we are getting. We could also implement the cross product of two vectors, but there are a lot of things, right? But again, this cross product gets implemented, right? And so again, like there are a lot of implementation that we can do, right? But let's see how we can use a at the rate operator. We are not implementing this cross product over here, but let's see how we can use this at the rate operator to implement this, right? For the at the rate operator, right, we can use, which is a symbol for the matrix multiplication, so we can use matmul method, right? So when we use v1 at the rate v2, it will call the matmul method. Again, we are not implementing it, but we are just trying to check whether this is correct or not, right? Let's run this. We have this two vector v1 into v2 will call the multiplications, right? And v1 at the rate v2 will call the matrix multiplication. We can see that when we use at the rate, it is printing the matrix multiplication over here, right? Now let's talk about the in place operator, right? So typically this in place operator will try to mutate the object on the left of the expression. That means it will not create the object, but it will try to create the, but it will try to mutate the object. For understand this, let's try to see the list. We have this list over here. When we check the ID of L, this is the ID we are getting. Now when we do this L1 plus equal to 3, this plus equal to is like a symbol for the in place operation, right? This is here we are doing this in place additions. So this operation will not create a new object, it will mutate the object. Now let's see what this means. So here when we do this, we can check the ID. ID is still same. ID is still same. That this object has not changed, and the list element has been added, right? But when we do this L1 equal to L1 plus list, right? We are adding this list with 3. When we do this, this means that we have the new ID. That means this is not in place additions. This is not in place addition. If you are not doing the in place addition, that means you will create a new object, right? And in place does not guarantee the mutation, because most of this because most of the objects are the immutable object, right? So if you do try to do the in place operation with the immutable object, right, that will not mutate. That means that will create a new object. Like with the tuple is the immutable object over here. So here we have this tuple. We are trying to check the ID before addition, and after addition we can see that we have the new ID. That means we have created a new object because tuple is non-mutables, right? Now let's go back to our vector class to implement the in-place addition. We can also use this in-place additions, right? But here we'll try to create a new vector. We'll not try to do this mutation over here, right? So here, let's see that in action. Right here, when we now this in-place addition happens when we implement the I add functionality. So when you do the I add, it will simply do self plus other, and that's it, right? So when we do this, here we have this two vector. We are trying to get the ID of v1. When we do this additions, right? When we do these additions, right? Now it is similar to add functions, but again, I add will try to make sure that it is in place or not. So here when we do this, it will try to call this method, and certainly it will call the addition method, right? Here we have this. So we can also print that. We can also print that here. Calling, okay, add calling, right? Now let's run this. When we do this, what we're seeing, when we try to do this, first we try to check the ID. When we try to run this in place operation, it called the I add method, and then I add method called the add method automatically, right? And this add method is returning you the new object, and here we can see that, right? We can see that we have the new object and we have got the new vector, right? Now let's modify this to actual mutate the vector, right? So for the mutation of the vector, here we have this I add, right? In this I add, we are trying to check whether this both belong to the same dimension and same object or not. We're trying to add the each element of the vector, and then we are assigning that tuple, the tuple of additions to the components value, and now we are returning the self object, right? So here we are just changing the element of the component, and that's it, right? We are not creating a new object, right? So the same updated element has been stored to the same object as well, right? So let's see that. When we do this here, we can see that the ID of v1 has not changed. That means we have not created a new object. So the ID we can see, right? Now there could be other use cases as well, right? For example, consider that again, like addition, subtraction, all this does not only depend on, does not only kind of use for the arithmetic operation as well, right? We can also do something else. Let's say that we have this for example, consider that we have this family class that hold mother and the father and the list of children, right? So then again, all this object, mother, father, and the list of children, all this object belongs to a person class, right? We can use this person class to create all the object, right? And we can simply add a element to the list of children. So here we have this person class, we have the object person. Now we are creating family. In the family, we have this mother, father, right? And now we have this children as an empty. Now we have this I add. When you call the in place addition, that means we are adding the element to the children. We are adding the element to this list, right? So when you add anything, that will be added as in children. You can see that here we are creating the object of family, and to create the object of family, now we are using the object of, now we are using the person object. Why? Because mother and father belongs to, can be a person class, right? So here we are taking the person class, we are checking the ID. Now we are doing the in place addition. This means that we are seeing the number of children over here. We can see that we have the one children. Now we are again adding the, now we are again doing this in place additions. This means that a new person is again added over here. We can see that this new person is added, and now this is the children, right? So this is the use cases of arithmetic operator, right? You can think, you can implement all this, right? And this is it. Thank you very much.